Good morning, everyone, and happy Friday. I'm really excited to have Shelly here with me today because she is from the foundry industry, and my whole perception of that industry was way off. Well, maybe it was okay a little bit, but I had like some probably old-fashioned ideas about that space. So Shelly is actually a principal engineer for KE Collab. So we're going to dive into that a little bit. But Shelly, please introduce yourself to our lovely audience and tell us a little bit about yourself.
Hello. So I am a materials engineer in the foundry industry, metal casting, and I have my own engineering consulting company that we provide casting design services, product development, as well as process improvement. And I also get to partner with a longtime pattern maker in our industry. And we do sourcing, and occasionally we get to redesign difficult castings. So that's a lovely challenge to take on.
So what would be considered a difficult casting?
Ooh, you're jumping right in.
So I heard it, and that's where my mind went. So I was like, "Ooh, what is
right that? Yeah. Well, a difficult casting to produce, and maybe I should probably start with like a definition of a metal casting.
Yeah.
Okay. So a casting is anything where you melt liquid metal and then you pour it into a mold and then you let it solidify and then you open up the mold and you have this beautiful shape. So that's a casting in a nutshell. And there are three different processes. I'm going to say three main processes for making a metal casting. There's the sand casting, the investment casting, and then there's a die casting process to do this. And the mold material is really the differentiation between all of those three. So the sand casting and the investment casting, the mold is destroyed every time. So it's got a repeatable pattern that is a hard tool and that stays, and then you make impressions. So the third kind, the die casting, you actually pour the liquid metal into a metal mold and it gets reused over and over again. So the mold is the pattern.
That's awesome. So is this something that you always wanted to pursue when you were like growing up, or did you even know what metal casting was? Because when I went to high school, they were just like, you're going to be an English teacher, and that was it. And I didn't really know about all of these cool things that were going on. So I get really excited when I have guests like you on teaching me new things. So how was your youth growing up, and what were some of the things that you were interested in?
So in school, I was pretty okay at like math and science, and everyone's like, "Oh, you should be an engineer. You should be an engineer." And I thought, "Okay, I'll be an engineer. That'll be great." So I applied to one university and one degree program, and that was biomedical at the University of Iowa. Got accepted, and 2 years in, we're taking like weed out classes. So it's like weed out chem, weed out physics, weed out math. And after 2 years, I was kind of crushed. Like, this is not what I expected engineering to be. I didn't think I was so successful at it. And so I left Iowa and moved home, went to the University of Northern Iowa because I'm from Northeast Iowa, which is my home university essentially. And I had no idea that UNI even had, and at that time it was called the Industrial Technology Center, and now it's called the Applied Engineering Building. But I took a class there, and I looked around and I realized that there were all of these amazing industrial playgrounds. I mean, highly engineered laboratories. So
love it.
It's like a playground. And they had them for construction, for printing, for electrical engineering. They had a materials lab, and then they had still have a full foundry at the university. So I was taking a 2D drafting class, and the professor goes, I think that you should look into getting a job at John Deere in the drafting department. And I was like, that's great. And he goes, and you should go meet the folks at the foundry because I think you're going to get bored behind a computer. So that's awesome. I didn't know there was a foundry here. Okay, what's foundry? And he took me back to the foundry, and I basically never left because, like, once you pour liquid metal, you're kind of hooked. Like,
it's super cool how they So what movie was it? It was like The Patriot or something, like a long time ago with Mel Gibson. Does anyone remember that movie? So there's a scene, and this is probably like, where are you going with this, Megan? There's a scene in there where he melts down these like metal soldiers that he was making before all broke loose, and he put it down, poured it in a mold to make bullets for his gun. And I thought that was the coolest thing ever. And I was like, huh, that's interesting. I wonder if that's real life. And what you're doing is like that.
But I have a little tin soldier upstairs, and if you'd have prepped me, I'd have brought him down for the discussion. Yeah. So it's like that. I mean, it's on that scale. That's a casting, and then we do everything. I think the largest casting I've worked on is an 80-ton steel casting for power generation. So it's everything. Wow. But on my computer screen, they're all like this big. So
right. So the other thing too that I was thinking about. So I'm a big CrossFit fanatic, maybe a slight addiction, but they have a video that's really cool. It's showing the whole process of how they make their bars, their weightlifting bars, and the beginning scenes of the 10-minute advertisement, which yes, I watched the whole thing because it was that cool, is the big bucket of just melted metal and then pouring it into these long bar molds. So everything is like hot orange and just super cool video, but it kind of is really dangerous, and like sparks are flying everywhere and everything like that. So I feel like that was my whole perception of this type of industry, but it's more high tech than that. And you, like you said, you see your designs on CAD and CAM, and there's complexities there. So I want to get more into that. So when you were going through college, what was it? Like you said, the melted metal and pouring it into something really got you attracted to it and wanted you to pursue it. What is it about this industry that keeps you here? Like, what do you like most about it?
Yeah. So, on LinkedIn, my colleagues are commenting like, you got to tell them this, you got to tell them like, so it reminded me of a story that when I was changing my major, I went to my grandpa because I grew up on a farm, and I went to my grandpa and I said, hey, I'm switching from biomedical to foundry. And he's like, nope. I was like, yep.
Disagree. Yeah.
Yeah. And his vision was of the old John Deere foundry that was dark, dirty, and dangerous. And that foundry is no longer. It was torn down. So at that time, what he envisioned and remembered was the dark. You couldn't see across the space. The brightest light in the foundry was probably the furnace and the wheels of liquid metal that might be swinging over your head. And then, exposed machinery and all sorts of things like that. And that was his vision of the foundry industry. And I said, okay, let's take a step back. And at that time, John Deere was having a milestone anniversary, and I don't remember what it was, but we were giving tours of the different plants in Waterloo and the foundries in Waterloo. And so I said, why don't you come with me and I'll give you a tour of the John Deere foundry, the new foundry. Okay, all right, I'll take a look at this. So I was able to give my grandparents a tour of the foundry, and it's lovely. I mean, it's a great space to be. It's clean. It's organized, it's automated. And that was over 25 years ago. And it's continued to improve over the years. But after we got done with the tour of the foundry, he was like, I get it. I see why you like this. It's this merger of your computer stuff that you absolutely love, as well as that hands-on, keeping your hands in the sand and making things kind of aspects. So it's the marriage of those two things. Yeah, so he was after that tour, he's like, okay, I get it. Go on.
I still think like the old school way is kind of cool though, but I may be because of my I'm kind of like, I love fireworks and like blowing things up. I just think it's cool. I don't know if that's like signal for something else, but I feel like with the traditionals, it's still cool to know about that, but I think especially now with like younger generations, they want to see that high tech stuff. And it's interesting to hear that it was automated so long ago. We do have comments pouring in. We have Hank. Hank, your comments are finally coming in. I'm super excited because LinkedIn for some reason doesn't like you sometimes. Hank has 2 daughters that watch Mavens all the time. They're called the # Junior Board of Directors, Aiden and Peyton. And they just love this kind of stuff. So I'm super excited that he's here. And he said, hi, Shelly. And he's like, I did work in a casting plant many years ago. They made brake drums and rotors, and sand casting was hot, stinky, and fascinating.
I mean, there's a smell. I'm not gonna lie. There can be a smell to it because of the binders that we use in the sand casting process. But yeah,
Yeah,
I've worked on brake drums and rotors as well, gray iron castings and ductile iron castings. So those are,
that's really
yeah.
cool. And then we have Tom, Shelly, my editorial recognition cast in metal. I don't know what that is, but okay, we'll check that out. And it shows the various awards that are cast.
Mhm.
Oh, so they like make the awards.
So
That's
the Oscars are castings.
that's cool.
Yep.
Now I want one, but I don't know what I would get one for, but that's okay. And then we have Frank Kai from Wisconsin. So one of the cool things was you posted this the promo piece, and you did have a lot of comments on there. And one said, let them know Foundry is not ancient and dirty, while another one said, one thing that often confused people in the difference between what they perceive of foundry work versus the modern industrial foundry. So how has metal casting like changed over the years to make it a really cool and fun place to
Yeah.
work?
So I looked this up before because I knew it was an old manufacturing process, but the first casting was made about 5,000 years ago. So it's quite the evolution. And yeah, so now we do things much differently, but the first casting was probably made in a sand mold, and we're still making things in sand molds, just in a much different way. So the biggest evolution, thinking about this, like 25 years ago, if you think about CAD being kind of a new thing, or not new thing, but a big push to get everything modeled in 3 dimensions, right? 3D modeling. And that offered us the ability to look at simulations, which are physics-based models. And then once we started running what we thought about castings, because, little tangent, I gave a presentation. I was 23, so I'm going to preface this story by I was 23. I gave this presentation about castings, and one of the audience members goes, how do you plan on quantifying an art form? Because the foundry industry, being so old, has this, I guess, reputation for being a black art.
Oh.
And I said, I have a bachelor's of science, not a bachelor's of arts. And I went on with my presentation. And my manager pulled me aside afterwards and he goes, hey, that was effective, but we're going to work on your delivery next time. And I go, okay, all right, I get it. So I have a bachelor's of science in manufacturing technology with an emphasis in metal casting, not a bachelor's of arts.
Right.
And these models allow us to really understand the science behind what we're doing. So once we start to understand the science, then we can see how and why things are working the way they do. And as designers and process engineers, we know that we have certain tools in our toolbox that we can do to adjust the outcomes. And when we understand like the equations and the science and the variables that impact those outcomes, we can pick the right ones, and then we can make those adjustments. And it's very efficient process to get shorter design cycles, less wasted material, less frustration. And it also increases our understanding and our knowledge of the situation. So it's education and training at the same time. And that's like how I learned fluid dynamics and heat transfer and residual stresses and strains, which is what I do on a regular basis now, is by that hands-on application and then using those computer models to really see inside of the mold. So it's a window inside of the mold.
Gotcha.
And I think that's kind of the biggest, over the last 25 years, that's been the biggest changes to the foundry industry is embracing the computer modeling, embracing the new technology, the PLCs, the software, the vision systems. And then, because I know that you also have a passion for this, once we started looking at the designs and said, okay, I can really impact the quality of the casting or the efficiency of the product if I can make these design changes or process changes. But the hard tooling that I mentioned earlier really limits us as far as features for manufacturability. And when we remove that constraint with 3D printing, then things start to get even more interesting and more complex. So that's been like the next evolution, is the application of printing molds and printing patterns and being able to remove those boundary constraints of traditional manufacturing.
So that was going to be one of my questions that I wanted to ask you, because you can use additive manufacturing to create some of these parts. So one of my questions was going to be, because it sounds like you can use it as a tool to print some of these castings and these molds.
Mm-hmm.
But when would you select additive manufacturing over metal casting or vice versa? Because how far that industry has come is amazing to me, because when it
Mm-hmm.
first came out, I remember writing for a media publication and everybody thought it was just going to be a fad or a hobbyist type of industry, because initially it was just printing out plastic material.
Mm-hmm.
And a lot of automotive and aerospace and aviation companies were like, no, we need like metal components and parts
Mm-hmm.
if you really want to scale this up.
Yeah.
So then you start seeing all these developments in like the powdered metals, and then copper used to be something they couldn't print, and now it's something they can print.
Yep.
And it's just amazing how far it's come. So like, when would you choose one over the other in certain situations?
Yeah. So let's see, how do I want to approach this? There's tangent, another story. So
Love it.
my senior design project in 1998
Mm-hmm.
was using polymer and wax 3D printed components,
Okay.
making an investment casting, which is using that printed component as the positive, and then you
Okay.
dip it in ceramic slurry and stucco, and then you build up a shell, and that plastic or that wax is still inside of it, but then you melt that out, and then you
Okay.
fire the ceramic shell just like you would your high school ceramics class, same
Mm-hmm.
thing. And then you're left with that empty ceramic shell, and then you fill that with liquid metal. So we made those in 1998 on John Deere's, really expensive at that time printers, and I cannot believe they let us run amok with their printers. Looking back, like, oh yeah, here, 22-year-old kid, have our $250,000 printer, have fun with it. Woo.
That's awesome. That's how things happen. You got to let people do that. That's cool.
I give so much credit to the people that have entertained my harebrained ideas and just ran with it. Because also the university that I went to wasn't a big investment casting university research center. It was green sand and chemically bonded sand. But I went to the foundry managers and I was like, hey, I want to do this. And they're like, cool. And they ordered a kit so that we could make investment castings. And then we flash fired those with an acetylene torch. And it was like don't try this at home, but we're almost professionals, kind of thing. And they turned out. These little things turned out. So that was a really great experience from multiple levels. Working with a team of my fellow students, and presenting it back to industry and getting feedback, and that's like, you're hooked then. Like, oh, I had a little success with that.
Yeah.
That's awesome. I'm going to keep doing that. So when my son, we have the Ender printer in our basement, he's like, oh, this is this new technology, 3D printing. And I was like, oh, sweetheart, no. So the application, we can do 3D printing in a couple different ways in our industry.
Okay.
We can make that pattern and make investment castings. And that's what my partner and I do for some of the parts that we source today. We'll make PMMAs, or we'll do wax printing, which is a little pricey, and cost is a big factor, of course. So we'll do those for maybe short run, complex things where we want to avoid cores, thin walls, things like that. So we'll do investment castings off of those 3D printed parts, and they're expendable. So we take those 3D printed parts, we burn them up, we fill the shell, they're gone. The other way we've used 3D printing is to print permanent tool, like a semi-permanent tool, I'll say, on a plastic printer, and then we use that to make the impression in the sand. So that's one that sticks around for a little longer, and we can make more pieces off of it. And then what you're talking about, the other thing is actually just printing the part directly.
Mm-hmm.
And that's not something I get too involved in, because that's a little bit outside of the scope. So if you're going to melt that part down, you can call me. But yeah, printing the metal is, I guess our industry could look at it as competition, but I don't feel like that's the case, because there's an application for everything.
Right.
So it's just finding the right, its design feature, its cost, speed to solution, functionality of the part. Because some of those printed parts are, 10 years ago wouldn't have been functional, but now they are,
Right.
because of the post-processing that's involved. Whereas they would look at maybe 10 years ago making an SLA or a PMMA or some kind of printed part, and then making an investment casting so it was a solid cast
Yeah.
part for them. So it's just understanding, the end use.
Yeah. So then with the actual mold castings, like how many different types of materials can they be made from?
You can melt it and pour it. You can make it. So for what we do, you could do, they could do titanium in a vacuum. You can do nickel-based, steel, iron, aluminum, copper, magnesium. Anything that's melted can be poured into the mold. It's just finding the right mold for it sometimes.
Gotcha.
Yeah. Mm-hmm.
But I'm learning so much. I love this. So then, what are you looking forward to in the industry? Because there's a lot of advancements happening right now in technology, and sometimes it's difficult because we can't train people fast enough, and we have this like skills gap. So what are some of the things that you're finding really excited and looking forward to with the metal casting industry?
I would say it's really embracing the science part of it, and being able to work with big data right now is a big thing. Like, I would love to bring one of my clients online with a big cloud-based data analytics tool where it takes all the information off their PLCs and their quality system, and we can analyze things from a top level perspective. So instead of looking at individual variables, looking at kind of an overall composite of what's causing things, because there's so many variables in the foundry industry. It's a very elegant way to make a complex shape. So that's just a fancy way of saying there's a lot of things that can go wrong.
That's fair. That's fair. Well, you mentioned too, like the biggest one that you made was like 80 tons. Is that what you said? So then what's like the smallest they could be?
I worked on rings, like jewelry. I think is probably the smallest thing that we've made. I can't think of anything smaller than that. But like ounces all the way up.
Do you have like a favorite project that you've worked on? Something that you didn't expect to do, and then you did it and you were like, wow, this is amazing. I would do this again.
I have a lot of those. So kind of the biggest, like, come full circle kind of situation, a knee implant. When that crossed my desk, I thought, this is like life, biomedical engineering, and here's this knee implant coming across my desk. So I've done knee implants or castings, metal castings. Right now, they'll transition away from this, so we will lose a little bit of casting in our lifetime, but that's not a bad thing. So they were cobalt alloys that I worked on, wear resistance, impact resistant kind of thing, and they're investment castings. So two different companies, and I worked on the gating systems for those. So how to get those filled as cleanly as possible and solidify so there are no holes inside of the knee and that kind of thing. So that was a really rewarding process, and those engineers, those are fun to work with. And then I worked on there was a sprocket that crossed my desk for the NASA crawler, which was pretty impactful, being a Gen Xer and being in awe of the NASA space program, to be able to touch some of those, well, not physically touch them, but mentally. Just work on some of those castings was pretty impressive. I worked on bridge components. So a suspension bridge has a saddle where all the wires come in. That's a metal casting. And manifolds for different flow applications, where it sounds kind of silly. The castings that I work on are generally safety critical components. They're foundational. So I take my job in that very seriously. I'm going to take myself very seriously, but
that's okay.
Okay, great.
That's also what life is supposed to be. I think one of the interesting comments that was on your post was what did the gentleman say? He said something like, "Oh, a lot of people don't understand that they're like 6 feet or 6 inches or something away from a casting. Like
Yeah,
you're
like
always near something that's been
yeah.
casted." And I immediately started looking around my room like, "Wait a minute, what? No way!" Like I just thought that was an interesting comment. So,
Yeah. Yeah. So
it's really.
like your cell phone is there's probably a frame inside of it, some magnesium die casting.
Mhm.
So your cell phone's a good one. Door handles, appliances have a lot of castings in them. Those are generally high pressure die castings, aluminum die castings as well. Lamp bases, all just looking around my room, all different kinds. So yeah, you're never more than like, a few steps away from a metal casting, and a lot of manufactured goods. I think the statistic is like 90% of manufactured goods have at least a casting in them. Um,
Yeah.
and that kind of thing. So I think the cutest title block that has ever crossed my desk, and I get to do this presently, is from Disney, because their amusement park rides have structural components in them, which are casters.
Yeah.
So the first time that I get this title block, I was like, "There's a Mickey Mouse like in the corner." And it's just
Oh,
so stinking adorable. And I get to work on those kind of parts. So, and like if you go and ride the Metra, because I'm in Illinois, if you go and ride the Metra, um,
mhm.
you know, you look at the bolsters and things on the trains, and you're like, oh yeah, that's Atchison. I can see the foundry mark on that, or that cast. I've worked on that bolster, or I worked on that knuckle. I worked on
That's really cool.
that
See,
wheel.
and I feel like people don't understand that like manufacturing is such a huge part of like how we live and are able to do things. And I think it just gets taken for granted because if you're not in this sector, then you really don't know like the complexities that go into how things are designed and made. And it's
Yeah,
just, yeah, it's incredible. So throughout your journey, like is there a lot of women in metal casting? Because again, like I mentioned before, I don't hear a lot about this space ever. Like right now, my feed is filled with like CNC machining and automation and robotics and additive manufacturing. So maybe that's like AI listening into like what I'm researching and everything. But metal casting, like Alexandria is the one that introduced us, and she was the
hmm
one talking to me about foundries. And I was like, we don't have a ton of foundries in the United States. Like, what are you talking about? She's like, yes, we do. We have a lot of foundries here in the United States. And I'm like, are you sure about that? Because I thought they all like left and went across the ocean. And she's like, no, like you're absolutely wrong. So that's how you and I got introduced to. So, like, where are we falling short on like an industry making people aware of the things going on in your industry?
So we're consumers of all those technologies that you talked about. So we're consumers of CNC, we're consumers of automation, 3D printing, all of these things. And
Mhm.
actually, we're drivers. We're not just consumers. We're drivers
Mhm.
of improving and adopting those technologies. Lots of research going on. We are like the customers, right? So I was talking about this morning. Little tangent again with the 3D printing company of sand molds. They said, well, if we as consumers demand that we need this particular binder that we're printing
Mhm.
with, then that puts pressure on the printers to put some R&D in this, because it's economics that drives all of this in demand.
Right.
So we are, I shouldn't say we're just consumers of this, we're drivers of what's needed for CNC improvements, what's needed for automation, what's needed for software, for
Mhm.
3D printing. Because we are foundational, like everything starts with the metal casting. And I think that's where we get lost in the messaging sometimes, is because we're just, if it needs to get done, we do it. You just put your head down, roll your sleeves up, and you figure out how you're going to accomplish these things. And it's like the workhorse of the industry. And we're also buried because, some of the castings that I've mentioned so far are kind of buried, right? Like you don't, except for the jewelry that's on display, like a knee replacement, you're not going to see that, hopefully. you might not notice a brake rotor or a drum in a car necessarily. Like I look at my calipers and my rotors just because, a casting geek. But like the train castings as well. So unless you know that they're there, you don't go looking for them, and we're okay with that as an industry. We're like, it's fine as long as we're doing what we need to be doing, and they're holding you up and they're doing and performing what they need to be doing. We're not out looking for credit, but I think we maybe need to flip that script a little bit and be like, hey, we make whiskers,
Yeah.
We make your car run and we make your car safe.
Yeah, I actually met she's a young marketer from Batesville Products is the company name, and they wrote.
Yeah,
I am obsessed with how they market their stuff because they actually have a kids menu on their website, and I'm like, this is fantastic. Like, why aren't more manufacturers doing this? And so she helped them develop a children's book, and it's very well written. It's very well illustrated. They made coloring sheets on their website. Some of the people that I know were like, coloring sheet, that's amazing. So then they started offering the coloring sheets. But she said that she goes to schools to talk to kids, and how they teach them about foundry work is they actually do chocolate molds. So they they melt chocolate and like put it in a mold and make chocolate candy, and that's how they teach them about the basic concepts of like what foundry work is. And I'm like, where were you when I was going through school? Because I just feel like I got duped really, really bad, because I just never, and like just melting things like you said and just pouring them in something and creating something, I think is very satisfying. Like I just feel like I've been duped.
I'll take it a step further from that too. Like I love that they're doing chocolate, that you can eat it and consume it. So my son is 16, and in our industry we do what's called foundry in a box. So we melt tin and make molds, and then the kids get to fill the molds with molten tin, because we pour it like 450 degrees Fahrenheit, so it's like a frozen temperature kind of thing. So when my son was little, I took him to Hobby Lobby and we went to the candy mold section. And I said, I want you to pick out some molds because I'm going to fill them with epoxy, and then we're going to glue them to follow boards, and we're going to make little patterns that we can do in foundry in a box. So he picked out like cars and ladybugs and butterflies and frogs and all these things, these candy molds. And then I filled them with epoxy, popped them out, we glued them on a board, and then my friend Sue, who's a metallurgist, her husband, they finished off the patterns, putting a little gate on them and a sprue and everything, so that we had these mini replicas of an actual production mold or a pattern, and that we can make molds off of. So then we fill those with reusable sand. So it's a oil binder that you fill that clay and oil and something else that's in there that's called K-bond sand. And then right now I use kinetic sand at home just because that's what I have available to me, and then make little patterns on our Ender 3 3D printer. So I've made little logos for different companies, and for my own company, I've made a logo to do these little castings, these tin castings. But we go to schools and use that to do the casting process discussion. And then, I mean, the kids get to make a casting and they walk away with something. And like the biggest joy is to have a kid come back in. And I do a lot of girls in engineering outreach as well. So to have most experience with the young women or girls, they come back in and they hold it up and they go, I made that. And the first time I was kind of dismissive. I go, yeah, you made that. That's great. And then I caught myself and I thought, oh, I do this every day. You don't. And I turned, I was like, yes, you made that. And that's really cool. Because it clicked for me like, oh, these kids don't have that exposure. Like I grew up on a farm, so it was very hands-on. And if something needed to be done, well, you were going to learn how to use a wrench and fix it. And you were going to do what you needed to do. But for the kids that come in today, that's maybe not the case.
Right. I'm like want to convince you to like maybe put those instructions somewhere and make them available so that like my kids would absolutely love that. Even my daughter, she's like 21 right now. Well, almost 20. She would even love doing that as well too. We have a bunch of comments coming in. I had to mute myself because I had a coughing attack, so I apologize for that. So then Thomas is posting the videos for those awards that are being casted, which is really awesome. Shelly is awesome. I believe she's awesome as well. And then we have Amanda Larson. You're amazing, Shelly. Great interview. Becca Resnick is on. Hi, Becca. Thank you for joining us. I mixed you two up in my first video, so sorry about that. But yes, cast prosthetic implants. I was thinking about this yesterday, working on translating the surgical guide for installing a hip implant. So my mom has 2 hip implants, and now I'm wondering if they're 3D printed or if they were metal casted.
That's a great question because, and the reason I say that we might be losing a casting to a different process is because, and this is a good thing, that they're transitioning away from metals, which are biocompatible, or no, bio-inert, sorry, I'm going to get the phrasing correct. So the metal castings are bio-inert to a ceramic, which is biocompatible, which means your body assumes it's the same thing. So it integrates that ceramic piece as part of its own bone structure, which is what you really want to have. Like instead of having a metal in a bone and they put some material on there so like the bone will fuse to the metal. It's a pretty cool process. That ceramic piece becomes part of that bone structure, and you don't have like stress risers and compatibility issues and rejection issues that you could have with the metal. So the hip implants were titanium, and then that ball socket's coated with some nylon or some material that can degrade in your hip joint, just like, you know, cartilage, but not be accepted, you know, by your body, to more of a ceramic material that is biocompatible. So your body
That's really,
a joint.
That's really interesting. Now I'm going to be like, Mom, what kind of hip implants do you have? And she's going to look at me like, what the hell are you talking about? We have Robert.
Get the brochure from her.
Is this metal? Like, what's in your body? We did casting back in the early 90s. What high school did you guys go to? Because I don't remember any of this being offered.
Some high schools, like Wisconsin high schools, for example, have foundry labs, and they're kind of like dusting them off now and doing more of those high school activities for metal casting.
I think that's super cool. Thomas, some really nice bright red Brembo calipers that you see on those high-end cars through those nice cast aluminum wheels, doing a great Maker Girl Mania this weekend at Clarkson High School with 250 young women. That's awesome. Please post content about that. I love seeing that stuff.
So just a little shout out for Tom. Tom has been an ally and an advocate for not just women in metal casting, but young people in metal casting. I think he's unsuccessfully retired from metal casting industry like 3 times now. You'll have to correct me if I'm wrong. But yeah, I mean, when you find somebody who's excited and passionate about this, then it's addictive.
It's funny that you said unsuccessfully retired. I know a high school teacher who is now out of retirement for the 3rd year in a row because he's teaching the carpentry teacher how to CNC machine because they couldn't find anyone to replace him. So he came back out of retirement to do that.
See, that might be like a nice segue into why young people should get involved in our industry.
Yes.
We need people. Like we need engaged, hands-on people who aren't afraid to get dirty, aren't afraid to make mistakes and fail. I mean, that for me as a female in the industry was huge. Like I thought I had to be perfect 100% of the time, all the time, never make a mistake. But that's the antithesis of engineering. At its core, it's failure, it's iteration, it's learning from those mistakes and then moving on. So if you have even a slight aptitude for any of the math or the science, or even just like problem solving, like you want to understand how things work and you're willing to try it and fail, record some data, learn and move on, that's when you get involved in our industry.
I like that you said that because in a previous interview that I did from an instructor from one of the Colorado universities, she was saying that a lot of the women engineers were like freaking out because she's like, there's like this perfectionist mindset with us. And she's like, so when it comes to engineering, they weren't used to failing. And it's like, no, that's okay. That's how we learn. That's how so she was like, even I had a hard time like wrapping my head around it. She's like, but I had a lot of good male mentors that were like, no, this is what engineering is. You try something out, you fail. And she's like, so yeah, I had to really like mentor them. Like, it's okay if it's not perfect the first time. Like, you want to screw up so then you can find the solution. And
Yeah.
it's weird that we have that. I feel like that's like a definitely a characteristic of being a girl.
And I think for me, because I've led teams, I've been on teams, I'm more gracious with other people than I am with myself. So to have one of my team members, my employees come into me and be in tears and saying, I'm failing at this, I can't get this done. And I'm like, okay, let's recap. Is the earth going to stop rotating tomorrow? No. Okay, great. We haven't created a black hole. No. Okay, good. let's parse this out into manageable segments. Like how are we defining failure? How are we defining success?
Yeah.
How are we gonna break this out into manageable segments and approach this? What did we learn from our failures? Because I want to fail again, but I don't want to do the same thing twice.
Right.
And then plan and move on. So it's not like me centered. I mean, in some ways it's me centered, but in some ways it's let's look at the data, let's look at the process, and let's enjoy the ride. Let's enjoy the learning process.
It's like supervised chaoticness or something. Like, just I don't know if that's the right term. Maybe we don't want to term it that way because then people are like, that's dangerous. I don't want anything to do with that. But yeah, so really like all the, and then Hank, my gals are so proud of what they make. I love that, getting them to try things out. They just sent me stickers of their logo, of their hashtag, and I was like, these girls are amazing. Like, I'm trying to get everybody to tag their hashtag because they love learning about our sector. So it's like, tag these girls because they really like knowing what's going on. So let's keep them engaged. So
okay, so I need to make some Foundry in a Box patterns for them. Yeah. And then give them the instructions for the sand and for the melting pot and everything. I bought my melting pot at Cabela's, so it's very easy to get. And the junior board of directors.
They would love that. They would be awesome. I'm trying to get out to Canada so I can interview them. And then, yes, bioresorbable
implants. Thank you.
And then you guys are making me read today on one cup of coffee. Osteogenic and osteoconductive, meaning they stimulate new bone growth and help it adhere to the new surface. That's cool. I'm going to be researching that later.
Yeah, so they would put that film on a metal implant so that it would and there's like a surface finish texture and things that they do so that the bone would grow and hold the metal implant in place as well. But that's cool. I think a little bit more so with the ceramic. Yeah.
That's super cool. Huh. And then Robert, McHenry, Illinois. Oh, you're right by me. Okay. So shout out to McHenry, Illinois, though, because they do a fantastic job connecting their community to manufacturers. So I went to their high school, and they actually have murals on all of their walls in their manufacturing section. And it's all of the major manufacturers that they have a dedicated mural to. It's awesome. And then their CNC shop is amazing. I was just I felt like I was in a shop floor. It was awesome. So why should younger generations then look into metal casting? Not just because it sounds fun and maybe slightly dangerous, but why?
Definitely for that reason. There are just under 500,000 people employed in metal casting in the United States. And there are about 1,700 foundries, by the way, in the United States. So just a little statistic, a little bit more than that, but we can say roughly 1,700 foundries in the United States. And I think 80% of them are small to medium-sized foundries. And then there's some really big foundries as well. So it's quite the gamut as far as employers, but also, and one of the LinkedIn comments was, remind them that there's more than engineering. So they're accounting, maintenance. It's like all different technical roles, all different types of roles within management, owners, business related roles, marketing related roles, like Alexandria, who does amazing marketing work
She's
for
awesome.
our industry. Yeah. And there's so many different opportunities to get involved with metal casting. That's not just engineering and not just the technical side, but also the business, the marketing, HR, those
Mhm.
kind of positions within the companies.
So how important is it to like keep foundry work alive here in the United States?
Oh. So the United States government has found it to be so important that they have, put their money where their mouth is, so to speak, in supporting the infrastructure, in supporting the DOE and the DOD, because I work with both on different parts, which is pretty exciting, and also just you get to give back in some way, kind of thing. So they've identified that these are strategic manufacturing positions to be in for our infrastructure. And I think that the pandemic also kind of identified that even though we're a global economy and we need to embrace the globalness of our economy, there is something to be said for being self-sufficient in certain means and ways. So I think that I know that the foundry industry isn't going anywhere in the next many years.
I'm just shocked that there's so many foundries here in the United States. Because again, I was just like, we got rid of that a long time ago, like textile, and I was completely off. It was so. I wish you were there when Alexandria like looked at me, because I was just like, I know. She's just like, no, like I'm going to introduce you to some people, and I'm like, please do, because I'm like, didn't know. It was such a cool conversation. She's awesome. I already asked you about the trends and kind of some of the future stuff, but what does the future look like for metal casting? Like, what are you working on, and personally, if you can talk about it? I don't know if you have an NDA, because people do that.
Yeah, a lot of my stuff. So I was looking through my projects. I was like, no. So a lot of it, and I was trying to find some common veins through all of the projects, and really technology, I think, is kind of one of the common veins. Using technology to understand the basic physics behind things. Like one of the product development projects that I work on is a combination that's hybrid of, we're using a university foundry lab to measure things, pour castings, and then taking that data and putting it in software and doing some analytics and optimization, which is my background and my love. Because then I get to learn from it as well, understanding things a little bit more. And every time that I have to explain it to my client, it's like a teaching tool for me. I can't explain it to myself. I'm not going to be able to explain it to the client. So it's learning a little bit more in-depth stuff. And every time you do that and understand the science and the background a little bit more, your product quality increases and what you can do with it increases. So your efficiency, your complexity, your end use gets better. Optimization of resources, because one of the other comments that was made was, we're the original recyclers. And I used to make a joke. I'm like, if it's not nailed down in the foundry, it's getting thrown in the furnace and remelted. And then not really a joke sometimes, because they were hurting for some scrap there for a while. But yeah, so we recycle the molding materials, the sand molds get recycled, the metal gets recycled. So I took a picture. I was up in Canada, and my mom's like, what do you guys put in the furnace? And I go, metal. She goes, come on. I know that. What else do you put in there? And I said, okay. So I took a picture of the charge piles.
Okay.
So the charge mix is what they call the product that goes into the furnace, like the ingredients. And I took pictures of the piles out there. So there are steel scrap from rail yards, from different types of like chewed up steel scrap that's in one pile that's been certified as a certain kind. And then you've got engine blocks and broken crankshafts and just different car parts that's in another pile. And then you've got beautiful pig iron, which is like the purified stuff that the smelters have done, and then they make this great mix that it's got consistent quality and high performance. And then you've got the returns, the internal returns from the foundry. So it's the risers and the gates and the sprues that were attached to the casting, the gating system, the fluid flow system. So that goes back in the furnace and gets remelted. And so I take a picture of this, and my mom goes, "Is that an engine block?" And I go, "Yeah, it is." She goes, I knew that everything got recycled. I just didn't have this vision of like an engine block,
Yeah,
this kind of thing. So I was like, yeah, that's what goes in the furnace. So that's an iron foundry. You know, they're gonna take a lot of different stuff.
That's really cool though, because one of the things that they're like tagging with this Generation Z is they're really big into sustainability. So like, I think that would be a great pitch for the foundry industry for them to get into. And I've talked to some of the younger generation. They're just like, yeah, I want to work with stuff that's like energy efficient and green and all this stuff. And I think it's a really like responsible thing to say from a kid. Well, I call them kids because they're younger than me, but they're young adults.
They're kids.
Yeah.
But so it's environmentally responsible, and it's resource responsible, and it's also economically responsible.
Right.
And that's really, you know, we're tongue in cheek. Economics really drives a lot of this stuff. Like, does it make economic sense to do things? And that's where the founder said, yeah, it makes a lot of economic sense for us to recycle the sand, to recycle, you know, the metal. These are finite resources, and we recognize that these are finite resources. But again, it gets back to we are foundational. So if we stopped making castings tomorrow, the world would shut down. I mean, seriously.
Yeah.
You wouldn't be producing cars, your power generation, your infrastructure, your bridges, you know, all these kinds of things are supported by our industry. And so it's one of those balances. Like, no, we don't want to destroy the planet, but yes, we do need to have a functioning infrastructure system.
Right. And that's why it's so important too to try to get more people into manufacturing, because it's not a good thing if that shuts down around the world. We had Mike saying, gotta keep things on shared, huh? Some companies just are so strict about those NDAs. It makes me crazy, because it's like, you have such a good story, share it. Gary said, I work with Shelly on many different projects, and I'm continually amazed at her knowledge in both casting and manufacturing in general. I've been in the industry for over 40 years, and she fits right in with us old timers. There are about 2,600 foundries in the U.S. In the 1950s, there were about 6,000. Wow. So, I mean, we did lose a lot, but we have, I didn't think we had any. That was my knowledge.
Yeah. So where we've lost foundries, we have capacity. So capacity changes because of automation. So the amount of castings or tonnage that a foundry is able to produce has increased. So we've been able to consolidate some of these foundries. And Gary is who I mentioned at the very beginning that the pattern maker I get to work with. He's a retired Navy, where I learned pattern making trade skills, and I get to learn from, you know, one of the masters in the industry, and it's awesome. Impressive. Yeah.
Thank you for your service too, Gary. I always got to say that to our veterans. And then Becca said it's also responsible in terms of human rights. Think about conflict minerals and conflict metals. Yeah.
That's a great point. So, you know, the previous president of our trade association, we were having a conversation about reshoring, and just kind of, you know, political things and not political things. And I said, you know, when you look at a U.S. made product, you know that the labor is being treated well, that our workforce is safe. We have OSHA requirements. We have EHS departments, and that people are making a living wage. It's not just a wage, it's a living wage. And it can be, you know, translated into a career as well, you know, just growing and promoting. A lot of foundries do internal training. They will send you to trade schools. They will send you to community college, to university. You want to do it, they'll support you.
That's awesome to know.
So buying, you know, products that are made in the United States is very responsible.
And then I did work at Story. We did a project at a metal plant in Indiana where they melted down metals and recycled it into sheet steel again, not foundry metal, but it was pretty neat to get the tour from the engineer there. They used very little raw iron ore there. That's really cool. See, it sounds like a great place to be, and I'm super jealous. I didn't know anything about it until like last year. So, Shelly, I want to thank you so much for coming on and joining me on Mavens of Manufacturing to share your story and just talk about metal casting. Because again, I think we need to do a better job at doing that. I know a lot of people, and you and Alexandria were like the two people that were giving me more information about Foundry than I knew, and I think that's awesome. I do want to ask you one final question for our audience. If you had one ask for them, what would your biggest ask be for them?
Oh, maybe just creating awareness. Again, you're never more than 10 feet from a metal casting or whatever the phrase is, but just if you can find a metal component, take a look at it and appreciate its complexity, its beauty, its shape. And if you happen to internet search it up and do how it's made, you're going to see how a foundry works and how a casting is made. And I think that once you start looking, then you're going to start seeing, more and more casting.
I'm definitely going to start being more aware of what's going to go on. I'll probably send you like a picture and be like, is this metal casted? Like, how was this made? But please definitely share those instructions, because I think that project you did with your son is awesome. And I want to do it with my kids, because anytime I can keep them away from like digital technology is a win-win in my book.
Integrate digital technology with hands-on activities.
Yes. I like that stuff too. They do like the STEM robots and stuff with their iPad, which is really cool, because I'm like, how the heck does this work? And they figure it out right away, and they're 5 and 6, and I'm just like, okay, I'm an idiot. That's all it is. Just a different generation. That's what it is. Well, Shelly, how can people get in touch with you, and what's the easiest way to contact you if they have any questions for you?
I would say LinkedIn is probably the easiest way to get in contact with me. So Shelly Dutler on LinkedIn, and a couple other resources that I wanted to mention that I really didn't get to, because we've talked about some amazing things. We're Foundry Educational Foundation. Again, this is where our industry puts their money where their mouth is. So the Foundry Educational Foundation provides tens of thousands of dollars in scholarships to university students for the metal casting industry. And the other resource is probably SWE for young women, SWE.org. So even if you're not in a university yet, they have what's called SWE Next, that is geared towards kindergarten all the way to 12th grade. So that's SWE.org. And then you can look up SWE Next on their website. And then there's a magazine called meltingpoint.squarespace.com. And that's kind of the scholastic reader for metal casting, if you will. It's a fun magazine that just talks about, it's geared towards, I would say, middle school kids kind of age, that age range, but talking about the foundry industry, jobs, how to get started. And it doesn't cover just engineering, it covers all the jobs in metal casting. And then what it is and all that kind of stuff.
That's meltingpoint.squarespace.com?
Correct.
Okay. I'm putting that in the comments so that everybody can take a look at it. I'm definitely going to go take a look at it. We did have Gary say, I like to use the term the faucet in your kitchen as a casting. And then Robert said, hand tools I use every day.
Also casting. Some of those are forging, but some of those are castings.
I'm going to be walking around my house now and asking my kids to pick out every casting. And they're going to be like, what the heck are you talking about? But it'll be fun. It'll be fun scavenger game. Well, thank you again, Shelly, for joining me today. I really appreciate the conversation. And to anyone that joined and put some comments in there, thank you so much for always supporting Mavens of Manufacturing. Next week, we have Becca. She was in the comments. She is a translator for technical information. So she will take information and translate it between German, English, and Japanese. And fun fact, translators are different than interpreters. And I didn't know that. I thought they were synonyms of each other, but they're actually different. So she's going to be talking about some of that and her experience in the industry. So I hope you guys can join us next week. And until then, have a great weekend. And thanks again, Shelly. It was great talking to you.
Thank you.
Bye. This episode of Mavens of Manufacturing has been sponsored by Z Ink Solutions. Z Ink Solutions. This isn't your grandmother's copywriting service. We provide copywriting and copy editing services that provide impactful text and memorable storytelling for a variety of brands and industries. Contact us today at zincSolutions.com. That's z-inksolutions.com.